Hello, good morning to all. Today we are discussing about convolution theorem. Here is the definition. If L inverse of f of s is equal to f of t and L inverse of g of s is equal to g of t, then Laplace inverse of f of s into g of s is f of t into g of t is equal to integral 0 to t f of u into g of t minus u into du. Simply we said that applying u in place of t in the first function and applying t minus u in place of t s in second function. Let us look an example. Find Laplace inverse of s square by s square plus a square into s square plus b square. Here f of s is equal to s by s square plus a square and g of s is equal to s by s square plus b square. Let us find f of t and g of t. F of t is equal to Laplace inverse of f of s. That is, we should have to substitute f of s in, that is s by s square plus a square in this formula. We get f of t is equal to cos a t and g of t is equal to cos b t. Later on, we should apply the Laplace inverse formula. Laplace inverse of s square by s square plus a square into s square plus b square, that is equal to cos a t dot cos b t, that is equal to integral 0 to t cos a u into cos b of t minus u into du. We should have to integrate with respect of u, and in this step we should change all the variables into from t to u and substitute u in place of t in the first function and substitute t minus u in place of t in second function. Later on we should do the integration like this, and it is in the form of cos a u into cos b of t minus u. Simply we said that it is in the form of cos a into cos b, and we have the formula of cos a into cos b. 2 cos a into cos b is equal to cos a plus b plus cos a minus b. Here what is missing? Here 2 is missing, so multiply and divide with 2. We get 2 cos a u into cos b of t minus u. It is in the form of 2 cos a cos b, and apply the formula of cos a plus b plus cos a minus b, and we get the result like this. And after solving all this, we get this, and the integration of cos is sine, and substituting all the values we get this step, and substituting the upper values of t in this step, and later substituting 0 in the second step, we get these values. And later on, by solving all of this and taking LCM, finally we get this step, and this is the final answer. And finally the Laplace inverse of s square by s square plus a square into s square plus b square is a sin a t minus b sin b t by a square minus b square. Let us look at another example for better understanding. Find Laplace inverse of 1 by s plus a into s plus b. Here first of all we should have to find f of s and g of s. F of s is equal to 1 by s plus a. G of s is equal to 1 by s plus b. Here f of t is equal to Laplace inverse of 1 by s plus a, and g of t is equal to Laplace inverse of 1 by s plus b, and we get e power minus a t and e power minus b t, which are first function and second function respectively. Laplace inverse of 1 by s plus a into s plus b, that is equal to e power minus a t into e power minus b t. We should have to apply the Laplace inverse formula in this step. Here integral 0 to t e power minus a u into e power minus b into t minus u into du. We should have to integrate with respect to du, that means with respect to u, and here we should have to substitute u in place of t in the first function and t minus u in the second function in place of t, and later on we get this formula. And by the formula of exponential, we should have to divide e power x plus y, that is equal to e power minus bt integral 0 to t e power b minus a into u into du. Here we should have to integrate with respect to u only. That's why we kept the u terms inside the integration, and here e power minus bt is constant. We should have to take it outside, and later on applying integration we get these results, and after all the cancellation we get this as our result, and this is our final result. It's very easy.